All right, this is part 2 of our lectures on fire. Our learning goals here differ slightly from the first part of our lecture. We're going to look at several examples of fire impacts in California, somewhat revisiting some of the topics here to reinforce them. But we're also going to look at fire management. In particular, we're going to talk about the differences between direct attack and the costs in terms to ensure fire-prone areas. We're going to examine how fire impacts are quantified and discuss other kinds of post-fire management problems. And lastly, let's revisit management because it's so important to our topic here. In particular, let's talk more about fire as a tool for mitigating fire risks. All right, so, what we didn't do last time was just look at some of the scale and scope of these problems. These fires, mega fires, are just that. They're really big. They produce a tremendous amount of pollution, and they're extremely expensive to deal with. They're expensive both in terms of the cost of direct attack, whether that's putting people out on the landscape to do back burns, to scratch line, or flying a DC-10 that's full of fire retardant. That is a major undertaking that CAL FIRE does in order to combat fires. And I'm glad to do it, especially when you've got a fire that's burning towards the town or city or some other critical infrastructure. So, but this is a substantial cost. And when you look at the staggeringly high costs of these fires, hundreds of millions of dollars, this is what that means. This is where that money is, those costs are being incurred. Now, part of our problem in California is that there is the taxpayers of California carry a tremendous cost of building homes in high fuel areas. When those structures can be insured against fire, when they're built and insured in fire-prone areas, those costs are transferred to the rest of us in the state. Those of us that do not live in high fire areas, we carry the cost in terms of the expense of insuring our homes and other properties. Now, one of the problems here, and this is not only restricted to California, this is an example from Southwest Oregon. Forced conditions, whether it's environmental that we talked about previously, such as adiabatic winds and other kinds of conditions, as well as fuel levels, can change rapidly. So you can have a situation where it would be reasonable to fire insure in some area because it's historically been wet or it has historically had low fuel levels, and yet those can change quite rapidly. And we have not come up with a good solution for dealing with those kinds of dynamic conditions. All right, so let's talk about how you study fire. There are a number of approaches that fire ecologists use to study fire, and here's one that's done at Humboldt State University. There's a fire laboratory at HSU, and where fire can be studied under controlled conditions. This facility is really cool. Bunch of drying ovens, you can dry fuels to different levels of moisture, and then they have actually a burn table where you can do experiments, measuring combustion levels and energy release within the lab, and that helps to model these processes in the landscape. That's what you're seeing here, measuring the fuel heights here, and then you can make other measurements to quantify the amount of material that was combusted and the total amount of energy that was released. So that's really great for looking at mechanistically how different species might affect fire dynamics, how different fuel moisture levels might affect fire dynamics, how arranging the fuel bed might affect the total amount of pollution that's released by the fire. But it is small scale. So in order to get a better idea of how fire is playing out on the landscape, we oftentimes need to go to remote sensing. There are a number of satellites that can do this pretty well. estimate healthy forests versus unhealthy forests, or actually measure the amount of energy that's released in the fire. So direct measurements of fire energetics could be really valuable, and I think they would be valuable not just for understanding the impacts of fire, but also combating fire on the ground. Fire intensity is a odd, or it's not really odd, but it's expressed in surprising units. It's expressed in units of work, which are watts or joules per meter per second. So the amount of work that is being created by burning all of this stored energy. It's hard to measure that in the field, and oftentimes we have to do it by proxy with some sort of indicator of how intense the fire was. Satellites are good at doing that. Satellite data is good at doing that, but it's actually a little bit harder to measure the fire intensity. We need that, and if you're interested in that problem, I hope you work on it because it would help. However, here's an example from the 2008 Basin Fire where the fire intensity, it can be measured remotely with satellites with a decent accuracy. And this is, of course, after the fire has happened. So we're working on it. We're getting there. There's definitely more to do. I want to emphasize that fire intensity and impacts are different things. Impacts would be things like mortality and loss of soil structure or release of pollutants. Whereas fire intensity is that work, the amount of energy that's being released during the fire. And the amount of energy that's being released during the fire is particularly important if you are trying to control that fire. Because if it is too intense, there are few tools that we have at our disposal for a direct attack. You can't send people to scratch line in front of a fire that has 100-foot flame lengths. It's, number one, it wouldn't do any good, and number two, you're putting those people into a situation that is absolutely hazardous, and one where they can't really do much good. So, fire intensity is a function of temperature and humidity at the time of the burning. That helps you forecast when you might have hazardous conditions, and again, when and where you may or may not, it may or may not be useful or responsible to send people out for direct attack. It's pretty interesting. The impacts of these conditions, oftentimes they don't. The intensity of the fire sometimes is influenced by things like the distribution of dead fuels, but not always. There's a lot of factors that are going on, whether you're measuring the fire, or the fire is occurring in a particular place at night or during the day, whether the wind is blowing very hard, and so on and so forth. Fire is extremely variable, extremely variable. You can look at it and you can see that there are problems, but quantifying its intensity and its dynamics they're quite variable. Okay, let's look at some fire impacts. It's exactly what you thought it was. I've already shown some examples of things like this, but fire burns stuff, burns all kinds of stuff, and often it takes burning stuff and then throws it directly up into the atmosphere. So it will throw up burning organic matter, a whole bunch of mineral material. It just makes a huge mess, both in terms of its effect on air quality and its effect on soil structure. The loss of soil structure is a quite serious impact of fire, and one that can take decades to recover from. Now, as I mentioned, ground fuels in particular can be problematic in terms of those impacts to soil, and here is an example of how they can be damaging. What this study is showing is that the accumulation of ground fuels led to increased mortality of redwood that one would otherwise expect to survive this particular fire. So these are intermediate sized trees here, but this is a period of time where there's a lot of ground fuel. This is conditions where there's increased transfer of energy from the fuel bed to the soil, damaging roots and leading to higher mortality of these trees. We're talking about trees that are 40 to 50 centimeters. It's a pretty big tree. It's a tree that you would expect would otherwise survive these kinds of fires, but did not, because the fuel conditions were quite different than one would expect historically. So, these kinds of extensive burns, there are a lot of problems that are associated with them. And just to be complete here, again, so you don't have to just take it from me, you can see these kinds of effects of accumulation of fuel on loss of soil structure or loss of soil carbon and nitrogen. That's what you're seeing here. This is the amount of dead fuels that accumulated in these stands prior to fire in terms of dead basal area. And what you're seeing here is that both in redwood and mixed evergreen forests, the more dead fuel you have, the greater your loss of carbon and nitrogen during the fire. And this is an example of phosphorus. It's one of the few elements that goes the opposite direction. And the reason for that is because it's difficult to get phosphorus into a gaseous form. So fire actually will lead to a depletion of soil carbon, soil organic matter, soil nitrogen, soil calcium, but it will tend to increase soil phosphorus because some of those elements go up into the atmosphere and phosphorus goes down into the soil. There's plenty of other kinds of impacts on soils. Namely, all the understory vegetation is essentially gone in this photograph, and most of the canopy is gone, at least for a few years. These trees are actually resprouting. They're California black oak. I pointed this example out in our last lecture. But it can be quite problematic in the ecosystem. In particular, the loss of soil structure, the loss of vegetation can exacerbate flooding. So particularly in 2016, the Big Sur area was impacted by dual catastrophes. A mega fire, the Soberanes fire, and then an extremely wet winter that caused massive erosion, scouring out of many of these forests. Took out a bridge on Route 1 through Big Sur, and actually caused the collapse of Route 1 in two locations, Paul's Slide and the Mud Creek Slide, that closed the highway for months and closed the highway between San Luis Obispo and Big Sur for, I think almost a year. I'm not sure. I can't remember. A long period of time. Post-fire conditions can lead to local flooding, mass wasting, as I mentioned, the loss of infrastructure. And it's also just a source of pollution to water, to surface waters itself, because this runoff is silty, it's basic, it has high levels of nutrients, and it can be problematic in that way. Here's another example of this kind of thing. This is a culvert that washed out. This culvert, I think in normal times would have been sufficient for the flows that we're going through here, but you can see that this all eroded out, and this particular road is still closed. This is Paulo Colorado Canyon Road, and this is an example of sediment deposition on top of a bridge here. Really problematic to the people who live up there. Okay, so I do want to point out, and this is where we're kind of coming back to the management here. We've been talking about fire as a problem, and it clearly is. But our forest ecosystems, our ecosystems in California, are adapted to fire. And fire also represents renewal in these ecosystems. There's benefits in that we get from fire occurring on the landscape. And these include renewal of forests, regeneration of trees, a creation of habitat that many plants and animals are adapted to. It also helps cycle nutrients. Some fire, under some conditions, fire is great. It is essential. It's part of how these systems function. So where is the middle ground between what we need which is clean air, clean water, and fire-safe communities, and understanding that fire is part of our landscape. Well, let's look to the past. Fire has been a traditional management tool, and it's one that is still widely utilized by California's indigenous people and indigenous people throughout the West. It's a management tool, and particularly in tribal country, up in Indian country, it's seen as an issue of sovereignty. And I think that this makes a lot of sense. These communities these communities are closely tied to forest ecosystems and the use of fire as an issue of identity. And being able to manage the resources be able to manage their forests for the resources that these communities need, oftentimes is going to be reliant on fire. Fire in order to cultivate plants that are important for the community, traditional foods, traditional medicines. Fire is important for sustaining those resources. Interestingly, I would point to tribal country, Indian country, as the leaders right now in terms of getting fire back on the landscape. I think if you go to these communities and you talk to people, you realize that you've got a group of people that are dedicated to this management goal, and they're dedicated to it in a way that spans multiple generations. There's a lot, I think, that other communities can learn from tribal communities and hopefully seek to emulate in order to get more fire back on the landscape. I can only see that as benefiting us in the face of this complex problem. Here are some examples of areas that are frequently burned up in, this is in the Yurok territory. Pretty cool, frequently burned area, one that's traditionally used for acorn and production and other resources. This is one of the most remarkable stands I've ever been to. This is essentially a nut grove, one that is managed for the production of tan oak acorns. I've never been in a stand. I've been in oak stands throughout the Iberian Peninsula and even in Italy that are managed for oaks, particularly production of oaks for the production of cured meats. One where the production of acorns is essential there. But these ones are very different and really neat. These trees are tended more akin to how one would tend a walnut or almond grove. Pretty cool. The species are definitely amenable, if that's the right word, to this kind of management. And it's really inspiring. It's my sincere hope that this will be emulated in more places, not just because the acorns are good, they are, but so is ham on Serrano. And I bet we could do some awesome ham on Serrano in California if we just get some, the tan oak acorns. Anyway, okay. Not just do these produce really good resources in terms of food production, they also have the structure that we would expect would be more fire resilient, meaning they're lower density, they have few ground fuels, and they're dominated by fewer larger trees. I think the answer to our wildfire problems are actually not as far away as we might think. They're a combination of things. Part of that is forest management. Clearly, forest management must play a role if we're going to deal with this problem. However, keep in mind, and I hope that you think back to some of the original things that we've discussed here, it's not just forest management. It's also much bigger issues. We can't make it rain, and we cannot control the rate at which snowpacks melt. Only potentially policy solutions and other kinds of problems or other kinds of approaches are going to allow us to do that.